Welcome to today's lecture and Introduction to Manufacturing. Today's topic is quality in manufacturing. I know when we think about manufacturing, usually quality isn't the first thing that comes to our mind, but honestly it should be. Whether you're a CEO or you're the person that is working, actually doing the maintenance on the piece of equipment, quality should be actually at the forefront of what we're doing or what we're thinking when it comes to manufacturing. You kind of have to remember that manufacturing businesses are in business for one thing, and that's to make money. In order to make money, they have to provide a very quality, a high quality product to do that, and it takes everybody throughout the whole organization to make that happen. So today, we could go into days and days and days of talking about quality. Today we're just going to really focus on generic terms, trying to let you understand what quality is, why is it important, and give you a good background on quality in manufacturing. So right off the bat, quality is the totality of features, characteristics of the product that bears on its ability to satisfy given needs. That's as per ASQC, which is the American Association of Quality Control, or ANSI. Just look at that real quick, and of course I like the very end, satisfy given needs, usually to a set specification. What is somebody saying that they want, and how well does it particular meet? So just like, say, your mouse on your computer there, somebody built that to a certain need. Was it to a specification, to a standard? Was it just kind of thrown together haphazardly and say, okay, here we go, this is a product that I do want to send out? I do like what Edward Deming has to say. He says the customer's, quality is the customer's definition of quality is the only one that matters. So what that means is, any given time, that quality could be adjusted one way or another, depending on what the customer feels. So in order, I think every product that somebody sells, you have folks who think it's, the quality of, say, your mouse on your computer here. I look at it, I may want a much higher quality where somebody else is comfortable with much lesser quality. So you really have to understand, if you're a manufacturer or someone who's concerned with quality, you got to find a fine line in there of where it's at. But keep in mind that quality is not perfecting and fine-tuning the product at the end of the stage of manufacturing. You're not at the last minute going to clean it up, put some nice lines on it, do whatever you need to do to make it look right, to give it, say, hey, it's high quality. But high quality is actually built into the product from every stage, from conception through the specification phase, to the design phase, through prototyping if that's what you're going to be doing, definitely through testing, and then all the way through the manufacturing stage out the door to the final customer. Because if you don't do that, then you're going to end up having the higher cost that's associated with that, higher manufacturing cost, or the cost of quality. And cost of quality is how much money is spent to build a quality product. And when doing that, you should consider the cost of not creating a product that meets certain quality specifications. So, anytime that I build a product that's not done to specification, I have to do rework, I have to redo testing, I have to redo assembly again, maybe redo my tools. All those things affect how much it goes into quality. If I would have built the quality from the get-go, from day one, quality built in, my cost is going to be much less. So you can look at it as cost of quality is any cost that would not have been expended if the quality was perfect from the get-go. So if through every stage of my process of manufacturing, I consider quality, I take the little time to make the little details work all the way through the end, not expending any more time, not expending any more money on resources, any more money on labor, that is what my cost to make this high quality product cost. That is cost of quality if I had to spend something extra. Total quality costs are incurred by investing in prevention of nonconformance to requirements. Maybe it's making sure that certain tests are done periodically through the manufacturing phase to ensure that I'm meeting my specifications to get a high quality product out the door. Appraising a product or services for conformance and failing to meet those requirements. You're going to have some that that do fail to meet those, and you have to understand how am I going to adjust and look at those to address that situation. But by building quality into your processes, companies are able to reduce the cost of quality, making it, building the fine-tuning in each step to have a quality product as you proceed, is you're going to reduce the cost of quality. Everyone is going to contribute to that. Not just the person, high up CEO, not just the supervisor on the shift that's doing it, not even the guys who are doing quality control. Everybody, including the guys that are doing the maintenance on the equipment. That equipment has to be running to its optimal ability at its tolerances that it's built for in order for it to be able to do that. So if a piece of equipment is not working very well, it might be causing to be equipment or pieces of the product in your subassembly to come out not quite to your specification, then you've got a problem. And so it has to make sure that everybody is involved with that to make sure your quality is there. Built-in quality means taking a proactive approach to identify and control errors. The goal is to eliminate any necessary rework, and it's up to the person, it's up to every individual in the system to say, hey, I'm not going to let it pass on. I see the problem here, whether it's my station that's calling or another station. I'm going to stop it here. We're going to fix it, and we're going to before it moves on to another. Last thing I want to do is get at the end of the day. I knew from 8 o'clock in the morning that I was producing an unquality part, and 10,000 pieces have been made. Now the company's got to step back, rework 10,000 pieces that I could have solved or stopped at 10 a.m. this morning. So kind of keep that in mind. Whether you're on like I said, on the assembly line in manufacturing or maybe in the maintenance side of it, everybody is going to be a part of that process. And individuals can do that by following your standard operating procedures, maintaining calibrated measuring equipment. Especially if you're on a quality control team, probably every so many parts you check, you want to double check your measuring equipment. Make sure it's still calibrated, make sure it's still reading what it's supposed to read, and kind of going from there. So it's very important for that. Built-in error proofing in processes can also help control the cost of quality. Make sure that you're taking, okay, can I take the human element out of it? Can I add a different, maybe a different checks and balances in that to check for error proofing? Those are all things that are important. But it is important that when an error is found, it may be necessary for you or that individual to stop the process and use problem-solving techniques to solve that problem. Typically, you'll have a standard operating procedure that will tell you what to do when that case comes. Because businesses, manufacturers who want to save money, they're going to have a policy in place to do that. But the effects of poor quality can be low customer satisfaction, low productivity, low morale of the workforce, rework, which is going to be very frustrating. When people have to step back and do rework, they're not being productive, and so chances are maybe their quality numbers or the production numbers are down. Those are all things that can also affect morale as well as cost. Inspection costs, delay in shipping. Right, we were supposed to have 10,000 units go out today. Well, we can't because we're having to go back and rework those because we didn't stop the process at 8 o'clock this morning like we should have, so on and so forth. Higher inventory cost, and definitely greater waste of material. A key element of process design is determining the impact of critical factors. Critical factors include aspects which present serious dangers to human life, human health, risk to the environment, or maybe potential loss of large sums of money to the manufacturer. Those may be while they're still manufacturing. Maybe they are at the end of the line. So if I'm making a manufacturing of an automobile and I know that this quality that I'm building is not quite safe enough so that at the end of the day I can hurt future owners of my cars, the drivers, maybe the people in the passenger seat or the back seat, those are critical factors. I am endangering human life or human health. So those are things that need to kind of know, and a lot of times human error is a large factor in that. And so looking at means to take control or reduce human interaction by allowing computers or allowing certain types of other checks and balances in place to do that are sometimes beneficial and definitely a factor to have for when it comes to quality. Errors by humans can be a lack of technique or skill. A lot of times that the manufacturing process, maybe it's the fact of the process itself. It's hard to train a human to do it, train a body. Maybe it's just the location of where this facility is at. You have a hard time finding skilled workforce. It happens a lot. So a lot of times that by humans or a labor force that's unskilled sometimes will cause quality to be brought down. So either you can train them, find a workforce training, work in more technology, but a lot of times it's just as simple as lack of skill. But sometimes it's a lack of instant feedback. Just like I mentioned earlier, you may go through 10,000 pieces before you realize that there's a problem. So that lack of instant feedback, as soon as that first non-conforming part moves through the assembly line, boom, there you go. Now you've got 10,000 parts that are out of conformance, and lack of instant feedback allowed that to happen. So maybe there's a way that we're using lasers or using some type of quality control technique, that you're able to try to get your lack of, or reduce that lack of instant feedback to a shorter time frame. So maybe only 1 part, 2 parts, 5 parts go through the line versus maybe 10,000 parts. So, and of course, even if you do have a skilled labor force, a lot of times just the labor inattentiveness is something that causes a problem, especially with quality. And you might have to find ways to adjust. Well, how can I keep these employees a little more in the game, have them paying attention a little bit closer? Maybe I need to rotate them out, more people in and out, so that the attention spans of my employees stay fresh or stay up to date while things are happening. So sometimes management needs to get involved and look at that too. But when corrective actions or when things do happen, you have corrective actions. Corrective actions are taken to repair a problem after it has occurred. Remember, it's a corrective action. These actions may especially include assign responsibility for correcting the situation, assess the importance of the problem, determine is it a critical defect, a major defect, or a minor defect. Make sure that you identify the negative elements resulting from the defect. How many parts were damaged? How many parts were affected? Identify the root cause. If you don't identify that, as soon as you turn the machine back on or turn the process back on, you're back to doing it again, right? Implement controls necessary to reduce that occurrence and, of course, dispose of any bad products. But I think the thing that's most important, I think we've all been in meetings in the past where sat there for an hour and a half sometimes. You walk out of the meeting and goes, well, who's handling that number one topic? Well, I don't know. Nobody assigned the problem. Boom, the biggest thing to do is to assign responsibility for that situation. If nobody's given that responsibility, then chances are nobody's out there working on it. So assign it to somebody, whether it's a supervisor, maybe it's you, maybe it's depending on what the defect really is, maybe it's a maintenance person, maybe it's a supervisor, maybe it's a CEO, I don't know, depending on how big of a problem it is, to reach out and solve the problem. But the biggest thing is to assign that responsibility to somebody or to a team, if not just somebody. You had corrective actions, but then you also have preventive actions. Preventive actions are taken to prevent a problem before it occurs. May include equipment maintenance, maybe the evaluating of your vendor. Well, I have a vendor that makes a certain subpart. Well, they've been lately producing some higher than average defects. Well, maybe we need to go back and find another vendor. Maybe we just need to go and jack them up and say, hey, you're not meeting specifications for me. It's time for you to get, you need to tighten up a little bit. Safety reviews. Anytime that you're not working in a safe environment, housekeeping is a big thing when it comes to quality too. If you're not working in a safe environment, you're probably going to be producing a very poor quality product. Personnel review. Maybe making quality incentives to your people who are putting it together. Hey, if we can reduce our quality numbers by 10%, we might be able to give you a 1% bonus at the end, or maybe this or that. So sometimes it's as simple as, hey, we're going to buy a T-shirt to everybody saying that we're quality. Our quality numbers were up. It's every little thing like that works. It helps build morale as well. And then of course design improvements. If your design team can build quality into their design from the get-go, chances are your end product is going to have a high quality of craftsmanship at the end because it's built in from the design. So today, that is a brief overview of quality. Everything we've covered today should get you through your exam. Wish you luck, and